Here's another problem or proof that we can do with a trapezoid. And I mentioned this when we were talking about the definition of trapezoids and all that. And this is going to show us that the median of a trapezoid equals 1/2 of both the sum of the bases, I should say. If we were to add up the length of DC and AB and divided it by 2, or multiplied it by 1/2, we would get EK, or the median of the trapezoid. And so let's get on into it. We have trapezoid ABCD with median EK. We have a median there, which means it is connecting the midpoints of the legs. All right, let's talk about this. We're, again, trying to prove that it is half of the sum of the bases. Number 2, let's draw a diagonal. I'm going to do a different color here, diagonal AC. And so now we have a new intersection here, or a new point. I'm going to call that point O. All right, we can draw this diagonal. I'm going to say draw AC. We can draw AC because, again, 2 points determine a straight line. Okay, number 3. I'm going to say something that may confuse some of us, especially if you have not looked at some of the previous theorems and corollaries that we have stated. I can say this, though. I can say that EK bisects AC. Let's take a look. I said EK bisects AC. I'm saying that this line cuts this line into 2 equal segments. I could have also stated that O is the midpoint, and we may say that in a couple steps here. But I can state that this line does bisect it because we've stated that since these lines are parallel, and we do know that the median of a trapezoid is parallel to the bases. We don't necessarily have to state that. We can state it as one of the reasons for stating things. But since we've already proven that, we can state that since this is also parallel, we have 3 or more parallel lines cutting off equal segments on these transversals. And so if we have just one transversal that is being cut into equal segments by 3 or more parallel lines, any other transversal will also be cut off into equal segments by those 3 parallel lines. And so we could say that. We've also stated somewhere, I believe, that the median of a trapezoid bisects the 2 diagonals, and it's because of that same idea. Because of the 3 or more parallel lines cutting off equal segments somewhere else on a different transversal, any other transversal will be cut off into equal segments by those 3 lines. Well, obviously where they intersect those 3 parallel lines. All right, so number 3, I can say really any of those reasons because those are geometric principles that we've covered. I'm going to just state this, that the median of a trapezoid, because it's the shortest, the median of a trapezoid bisects the 2 diagonals. And obviously I only drew 1 diagonal, but it's true. It does bisect the 2 diagonals. If I were to draw this diagonal as well, it would bisect that. And so that would be true. Because, again, it's just another transversal going through these 3 parallel lines. And so there it is. Number 4, I can say that E is the midpoint of AD. E is the midpoint of AD. And K is the midpoint of BC. And that's just simply because the definition of a median. Definition of median of trap. That's literally what a median does, and we've talked about that in the definition section, that a median joins the 2 midpoints of the legs of a trapezoid. Number 5, now I'm going to state that O is the midpoint of EK. All right, we did state that EK bisected AC. Oh, not EK, sorry, of AC. O is the midpoint of AC, of the diagonal. So right there, it's cut into two equal spots. We've already said that it is bisected, and we just now specifically said that O is the midpoint. It's important because of the next step we're going to say. But we can say O is the midpoint of AC because the definition of a segment bisector. Definition of segment bisector. All right, number 6. This is why this was important. We can now say that EO equals 1/2 of DC. We're also going to say that OK is 1/2 of AB. Let's take a quick look at what I just said. I said EO is 1/2 of DC. What in the world? That seems super abstract. Why in the world can I say that this part of the median is 1/2 of this base? Let's remember. It's so important to remember theorems, corollaries, postulates, axioms that we've learned in the past. You have to keep bringing it to the future. The more you remember, the easier proofs will be. And so if we were to focus only on this triangle right here, look at what we see. We see a line joining the midpoints of a triangle. I hope your brain's already recalling what that does. We have a line joining the midpoints of two sides of a triangle. It, first of all, is parallel to the third side, but it is also half the third side. So EO is 1/2 DC because it is 1/2 the third side and it's joining the other two sides' midpoints. The same thing is true about OK. Now we have a triangle here. And OK is joining the midpoints. We've stated all the midpoints, that K is the midpoint here, O is the midpoint here. So OK is joining the midpoints of two sides of this triangle. And so OK is first of all parallel. Don't necessarily need that in this proof, but we also stated that this line would also be 1/2 of the third side of that triangle as well. And so let's state our reason here. I can say number 6 reason is the line that joins midpoints of two sides of a triangle is parallel to the third side and is equal to 1/2 the third side. Number 7. Now we're going to use just a little bit of algebraic kind of thinking, really just mathematics thinking with these sides. I'm going to start saying that EO plus OK equals 1/2 DC plus 1/2 AB. Let's see what I'm saying. I just stated that EO plus OK is equal to 1/2 of DC and 1/2 of AB. Why can I say that? Substitution. I said that EO is 1/2 of DC, OK is 1/2 of DC, so really all I did was added equal quantities to equal quantities. EO equals 1/2 DC, so EO equals 1/2 DC is still there. If I were to just subtract these things, this statement would be true. OK equals 1/2 AB, OK equals 1/2 EB. If I were to get rid of those equal quantities, this statement would be true. So I'm just adding equal quantities to equal quantities. Those are quantities equal to each other, and I'm just adding it to these equal quantities. So that's just our addition axiom that we've learned. Addition axiom. Number 8, I'm going to state something extremely basic. EO plus OK equals EK. Oh man. EO plus OK equals the whole. Hallelujah. That's pretty simple. The whole is equal to the sum of all its parts. Number 9. We can now say EK equals 1/2 DC plus 1/2 AB. This is again substitution. Oh, I guess this is not even the first. This is the first time we've used substitution in this one. And then number 10, so all I did was substitute here. Up here I said EO plus OK equals that, so we kept that the same. But then here I said EO plus OK equals that, so I just substituted EO plus OK for EK down here. All right, there we go. And now we can just do some algebraic simplification. We can factor out 1/2. We got 1/2 in both of these terms, and we can do the reverse kind of step of the distributive property that we've learned in algebra. Pretty basic property there, but we're just going to factor out 1/2. So we could say that EK equals 1/2 DC plus AB. Really 1/2 of the sum of DC plus AB. And that would be just simple algebraic simplification. And there we go. We just proved that the median of a trapezoid is equal to 1/2 the sum of the bases. Test.